ahead and fill in the table values. And go ahead and graph it. Okay, so you're starting with y equals 2 to the x. All right, so I know 2 to the third is 8, 2 to the second is 4, 2 to the first is 2. Everybody, what's 2 to the 0? 1. 2 to the negative 1 is 1/2, 1/4, 1/8. So let's go ahead and plot these. So this is an exponential function. Then what I want you to do is pick a new color. And what we've learned is logarithms are the inverse of an exponential function. So that means I can take the exponential table and switch the x and the y values. And so let's plot those. I have 8, 3, 4, 2, 2, 1, 1, 0. Now look, when I do 1/2, it's -1, 1/4 is -2, 1/8. So something that's really, really, really important is the way that I'm going to show you how to graph these. It's going to be the easiest way I think you can do it. However, do you understand it doesn't stop at 1, 0? This does shoot down to -infinity. That's going to be really important that you remember the general shape. So here's what's interesting is we kept doing our arms. This was our exponential, but then now a logarithm looks like this. It's got a vertical asymptote there. What do you notice about the relationship in the table? The x and y values are switched. The graphs are a reflection over the line y equals x. All right, what I want you to do is I'm going to pause a moment, and I want you to tell me the domain and range of our graph on the left, y equals 2 to the x. And then I want you to tell me on the right side, what is the domain and range of the log graph? And I want you to stop and think about what we did with inverses and why those domain and ranges are what they are. So today we're doing 4.67. There's a homework that's due tomorrow. Then tomorrow we're going to play a game, Gobble Gobble, where we're just going to press pause and practice everything we've learned so far in the unit. Next week, I plan, when we get back from Thanksgiving break, to do another day on the graphing, and then 2 days review and a 2-day test. Okay, so that's where we're headed. All right, so what is the domain of y equals 2 to the x? Avery, what'd you write down? That is correct, because the graph goes left forever and right forever. All right, then Max, what did you write down for your range for y equals 2 to the x? Good job, 0 to infinity. Then Brennan, what do you know about inverses? You switch the x and the y. So Hannah, what would be the domain then of the log? Good job, you're just switching the range to the domain, okay? And then Matthew, what would be the range?
Negative infinity to infinity.
Okay, good job, negative infinity to infinity. All right, so remember all your left, right, up, down, stretch, shrink, and flips. It all applies to logarithmic functions. So if you notice, and I put it all here, if the absolute value of a is bigger than 1, it's a vertical stretch. If the absolute value of a is less than 1, it's a shrink or compression. If a is negative, it's a reflection over the x-axis. When h is positive in here, okay, so like for example, if I have x minus 3, that's right 3. If I have x plus 2, that's left 2. When k is positive, it's up. When k is negative, it's down. Now, logarithms have a vertical asymptote. And the vertical asymptote is x equals the h value. And we have something called a reference point. My 1, 0, if you're moving to the right, h, you would just add 1 plus that h value, and then it would be k, up k. If I have b, 1, it'll be b plus h, a plus k. You don't really need to remember that, but that's just helpful. So what we're going to do now is we're going to look at an actual graph. And there's a variety of ways you can do this, okay? But the way I'm going to show you, we'll see if this makes sense. If it doesn't, ask me individually, and I'll show you a second method. I just don't want to cloud the brains with different methods. All right, so here, my parent function is y equals log base 2 of x. So here's what I want you to do. We're going to put what 2 to the 0 is. 2 to the 0 is 1. 2 to the 2 is 2. Or excuse me, yeah, 2 to the 1, and then 2 to the 2 is 4. 2 to the 3 is 8. So we're putting all the powers of 2 starting with 2 to the 0. Now I want you to stop and think about the y values. This would be y equals log base 2 of 1. Well, what is, in general, the answer to a log? An exponent. So 2 to what power is 1? 0. And then we're doing y equals log base 2 of 2. So 2 to what power is 2? 1. Y equals log base 2, 4. 2 to what power is 4? 2. And then y equals log base 2, 8. What are the domain and range of this parent function? Remember, logs are 0 to infinity, and the range is negative infinity to infinity. If you're asking me, how do I know that? We just did this together right here. We just graphed y equals log base 2x and said the domain is 0 to infinity and the range is negative infinity to infinity. Now, what are the transformations? What's happening to f of x? It's plus 4, but what's that mean? Is it left 4? Is it down 4? It's up 4, right? This is up 4. If I meant for it to go left, what would I have needed to make this go left? Parentheses, right? Around the x plus the 4. And that's why I've been intentional about my parentheses so that it's really clear. So here's my mapping notation. Well, let me change that. What is the mapping notation if I want this up 4? William, what do you think?
X comma y plus 4.
Good job. X comma y plus 4. So now, is it domain or range that's impacted by up and down? Range, good job. So, but my range is negative infinity to infinity. If moving up 4, does that impact negative infinity to infinity? So here's a big idea. Any transformation up or down on your y's never changes the range because it's still going to negative infinity to infinity, okay? What's going to impact my domain? What kind of transformation? Left, right. Now there's another one that will impact it. If I reflect over the y-axis, that'll do it too, okay? But I had no change in x, so that's 0 to infinity for my domain, and my range didn't change. My vertical asymptote didn't change. So let's fill in a new table with the mapping notation. The x's didn't change, but my y values went up 4. All right, so here's my vertical asymptote. You do need to sketch it. I have, now be careful how this scale is. I have 1 comma 4. This is going by 2's everywhere. Now don't stop. This will cross. Now it did ask me for the y-intercept. So to find the x-intercept, let's write ourselves a note. To find the x-intercept, let y equal 0. So I'm going to do 0 equals log base 2x plus 4. All right, well, I'm going to subtract 4 from both sides. And then I get 2 to the negative 4 equals x. When you're trying to solve for x and it's inside a log, I just go from logarithmic to exponential form. What's 2 to the negative 4th power? 1/16. So my x-intercept is 1/16, comma 0. So you can always find the x-intercept by letting y equal 0. Oh, then do you see why we solved equations? That makes sense. All right. So make sure you always sketch the vertical asymptote. All right, number 2. What's my parent function here? Good job. Log base 4 of x. The domain is 0 to infinity, and the range is negative infinity to infinity. Let's make our table. So it's going to be powers of 4. So 4 to the 0 is 1, 4 to the 4, 4 squared, and 4 cubed. So then that's 0, 1, 2, 3. again, where I'm getting 1, 4, 16, and 64 are powers of 4. 4 to the 0, 4 to the 1, 4 to the 2, 4 to the 3. And then the answer to a log is that exponent, 0, 1, 2, 3. All right, what are my transformations? I see 2. Emma, can you give me one of them?
Left 6.
Good job. That's left 6. Humira, what's the other one? Now it's a 3. Vertical stretch of 3. Now what I want you to notice is this is the exact same that we have done with absolute value, with quadratics, with square roots, log. We did it with exponentials. Now we're just doing them again with logarithm. So what would be my mapping notation? Drew, what do you think?
Y minus 6 plus 3.
Nope. No, you're starting, if x is going left, we need x. X minus 6, that'll do the left, and then we're doing a vertical's y, and we're making it a stretch. So what's that going to look like? Y times 3. There you go. You got it. All right. So now, my domain. I have moved left 6. So Nick, if I'm going to move left 6, what would be my new domain?
Negative 6 to infinity.
You got it. Now, it does not matter that I've multiplied the y values by 3, because negative infinity to infinity, you can't change that. So let's send our points through the mapping notation. So what the mapping notation says is take all of the x coordinates and subtract 6. Take all the y coordinates and multiply by 3. All right, my vertical asymptote changes with a left-right shift. So now my vertical asymptote, does anybody want to try it? What would the vertical asymptote be? Gabe, what do you think? Instead of it being at x equals 0, okay, initially the parent function vertical asymptotes are at x equals 0, and now I've moved it left 6. Yep, you got it. X equals negative 6. So let's go to x equals negative 6, and we're going to make our vertical asymptote. Now I'm going to plot as many of these points as I can. Don't forget that this does come shooting down, even though I didn't get those points in the table. Okay, this is critical. This is absolutely critical. This needs to be shooting down all the way to negative infinity because our range is negative infinity to infinity. I always have 1 or 2 students who stop right here. And I'm like, you said the range was negative infinity to infinity, then your graph doesn't show that. Just make sure you continue that. Oh, nice. Our x-intercept is in the table, right? So most of the time, your x-intercepts will be in your table. So that's just negative 5, 0. All right, if you have your graphing calculators, go ahead and grab those. And we're going to do a little exploration. And it says f of x equals e to the x. And here's what I want you to do. I cut my table off accidentally. I want you to plug in e to the negative 2 and just write down, maybe 3 decimal places is fine. Go ahead and fill in your table. Do e to the negative 1, e to the 0, e to the 1, and e to the 2. Then go ahead and start plotting those points. All right, I'm going to go ahead and fill in what I got. At negative 2, did you get around 0.135? Negative 1, 0.368, 1, 2.718, and 7.389. So this is exponential, okay? This is an exponential function. So the domain is negative infinity to infinity. The range is 0 to infinity. I have a horizontal asymptote and a y-intercept. So I'm going to sketch that. So note that these are going, my tick marks are going by 2s. Now we're going to switch the x and the y values. And we're going to plot these. So I have a 1, 0, 0.135 is down at negative 2. 2.718 is at 1. In general, what function is an inverse of an exponential function? A logarithm, okay? So exponential functions and logarithmic functions are inverses. So my domain now is 0 to infinity. My range is negative infinity to negative infinity. I now have a vertical asymptote of x equals 0, and I have an x-intercept of 1, 0. And remember, inverses are reflections over the line y equals x. All right, what is the equation of the inverse of f of x equals e to the x? What logarithm would it be? You know, Mia? What do you think it is? It's natural log of x. So think about this, okay? Think about this. If I'm starting with y equals e to the x, what do you do? What's your first step in an equation to find an inverse? Switch x and y. So I would make this x equals e to the y. So I switch x and y. Then what was step 2? Well, you're trying to solve for new y, right? And then I'm going to do exactly what you're saying, is then you want to solve for new y. And so that would be log base e of x equals y. And that's just natural log. And I'm going to call that f inverse x. And something I'm going to start working on, I was reading, just how to better help students learn and retain information, because this year we've seemed to have had a lot of difficulty retaining what we're learning. And one of the things was having students explain what they're doing. So I'm going to be trying that periodically. So I want you to notice I'm starting to do this. So then you should be able to look back through the notes to say, okay, what did we do? One other thing is you can rewrite in log form. So I'm trying to do this because eventually I'm going to start asking you to explain what you're doing. We'll see if that helps. All right, so now in this group, 1, 2, and 3, I want you, the function f of x equals log of x plus 1. They're saying that's my parent function, okay? That's what they're saying is their parent function. If you reflect it across the x-axis and down 4, what would be my new equation? They're saying you're starting with f of x equals log x plus 1. If I want to reflect it over the x-axis and shift it down 4, who would like to give us their equation? Avery, what do you think?
Would it be negative log x plus 1 minus 4?
Good job, you got it. And just call it a different letter. You can call it y is okay. Just don't call it f of x. You can call it anything else other than f of x. All right, number 2. The function f of x equals log base 8 of x minus 3 is compressed. What's another word for compressed? Shrunk, I guess maybe. Shrunk vertically by a factor of 2/5 and translated up 11 units. Go ahead and write your equation. Call it anything other than f of x. All right, Elise, what'd you get?
G of x equals 2 this log x, 8, and parentheses x minus 3 plus 11.
Good job, you got it. You can call it g of x, y, anything you want. The function f of x equals negative log base 9 x plus 4 is translated to the right, right 4 units and 1 unit down and vertically stretched by a factor of 7. Try this one. Very interesting. Write down what you think. All right, if you're sitting in the pi seat, pi, tell the E what you wrote down. If you're by yourself, turn around or talk to the people in front of you and listen in.
I said y equals negative 6 log 9 x and x minus x minus 1.
I did. Shouldn't it be minus 4 and then you're adding 4 on the right, so it would just be 0? So you just write x. I don't know.
All right. Okay, Mackenzie, what did you write down?
Negative 7 log 9 times. Of x minus 1.
You got it. And so what happened is you had x plus 4, but when you moved it right 4, that's subtracting. So then that does land with x. All right, in this next group, describe the transformations. And you're assuming the parent function, like in number 13, would be log base 2x. So write down all the transformations for all 4 of these. Do as many of them as you can. Then when we're done, I will pull up my 4.66 homework and we'll go over as many of those as we can. All right, check 13. Make sure you're off to the right start. Vertical stretch of 5, left 2, down 1. Keep going, keep working. All right, number 14, going across. Reflection over the x-axis, left 5, up 2. Number 15, vertical stretch of 3, right 4, down 2. Now you ignore the negative sign when you do your stretches and shrinks. Okay, that's what that absolute value of A meant. So it's a vertical stretch of 2, left 9, up 3. Can you give me thumbs up? Did we get that okay? All right, good, good, good.